To better understand how distance PPG algorithm combines the pulse signal from different regions of the skin surface to improve the overall signal strength, let us look at the signal model. YIT is the camera measurement at location XI on the skin surface. IXIT is the intensity of the light falling on the skin surface at location XI. Alpha XI times PT is the pulse signal that we are interested in, where alpha XI is the amplitude or strength of the pulse signal and PT is the normalized pulse signal. BXI is the surface reflection at location XI and NIT is the camera measurement noise at location I. The value of alpha XI changes all over the skin surface due to variation in the density and depth of the arteries and veins underneath the skin surface, and the value of alpha I is not known a priori. If we accumulate all the measurements from different pixels of the skin surface, then we get measurements from YI to Y1 to YN, which can be modeled like this, and what we are interested in is to find the weight GI that is needed to combine the measurements at different pixel locations so that the overall strength of P hat T, that is the pulse estimate, is maximized. The way distance PPG algorithm identifies the weight GI is by looking at the pulse signal or the measurement at location I in the frequency domain and then defining a SNR like metric where the signal is defined as the periodic component of the measurement and the noise is defined as the power of the non-periodic component. To be specific, let us look at this frequency plot of the measurement at a particular pixel where the periodic component is shown as a peak and the energy in the periodic component is defined as the signal and the energy at the rest of the frequency band is defined as the noise. And so the goodness metric is the ratio of the green part upon the red part, and this is a plot of the goodness metric in different parts of the skin surface, and we can clearly see that the distance PPG algorithm succeeds in identifying regions having higher signal strength that are in the forehead and the cheek region, and also identifying regions having low signal strength which are in the eyes and the chin region. Here we have shown the pulse signal extracted at different regions on the skin surface. 1 is on the forehead, 2 is on the cheek, 3 is on the chin, and 4 is on the eye. Clearly the goodness metric applies the weight, higher weight in regions having better signal strength and lower weight in regions having lower signal strength, so that the weighted average YT, which is the pulse estimate, is very close to the ground truth pulse estimate that we recorded using a pulse ox, that is a contact method. If we compare the SNR improvement that the distance PPG algorithm provides, it provides as high as 6 to 7 dB SNR improvement for darker skin tone if we use this weighted average technique compared to a normal averaging.